Hi, in this video, I will be showing you problem number 9 of chapter 10 section 1. Sketch the curve by using the parametric equations to plot points. Indicate with an arrow the direction in which the curve is traced as t increases. Part B, eliminate the parameter to find a Cartesian equation of the curve. X equal to square root of t, y equal to 1 minus t. So here we notice x equal to square root of t. So this clearly tells us t must be more than or equal to 0 because negative values of t is not allowed when x equal to square root of t. So we'll start off with t, give values for t starting from 0. Then to indicate the nature of the graph we need at least 4 or 5 values. So we'll go start at t equal to 0 and stop at t equal to 4. We can go more. But we are only going to give the indication of the points. So we'll substitute t equal to 0 into the first relation x equal to square root of t and get the corresponding x. Similarly, substitute t equal to 0 and find out y from the relation y equal to 1 minus t. So we get when t equal to 0, we get the point 0, 1. When t equal to 1, we get 1, 0. When t equal to 2, we get 1.414, which is the value of square root of 2. And then y coordinate is -1. When t equal to 3, x equal to 1.732, which is square root of 3 value. Then y equal to 1 minus t, which will give us -2. When t equal to 4, x equal to 2 and y equal to -3. Now we are going to plot these points in the Cartesian graph. We'll plot these points in the x and y coordinate system. So t equal to 0 corresponds to the point 0, 1. And then t equal to 1 corresponds to 1, 0. Then we can plot the rest of the points. And then when t equal to 4, it reaches 2, -3. So the arrow is shown starting from t equal to 0 in the increasing value of t. So the arrow is important in a parametric graph. The parametric graph not only tells where the points are, it also tells when the particle attains that position. So that is the difference between Cartesian curve and a parametric curve. So for the second part of the problem, we are asked to eliminate the parameter t to get the Cartesian equation of the curve. X is given to be square root of t, so we'll square both sides. That will give us t equal to x square. And then y is given to be equal to 1 minus t. So if you substitute t equal to x squared into this, you get y equal to 1 minus x squared, which clearly we know is an inverted parabola. And importantly, we have to also see the domain here. So as t is always positive because it's a radical t for x, t is more than or equal to 0. This gives us x is always positive. X is positive or 0. So we are only tracing the right side of the parabola. So in this graph, in the previous graph, you notice that we don't have the left part of the inverted parabola. We have only right part of the inverted parabola. This is because of the fact that x is more than or equal to 0. Hope this video helps.